Okay, welcome to the double displacement reaction lesson. So far, we've covered a few different types of reactions. So we've looked at, in general, synthesis and decomposition and the combustion reactions. We've also studied in more detail the single displacement reactions last day. We're going to move into the double displacement reactions. So you should know how to identify them. There's a compound that comes in, another compound, it reacts with this other compound, and then what happens is like the metals will swap places and pick up the other not metal, and so forth. So then you get these new ionic compounds as products. Okay, so we're going to look at double displacement reactions in more detail today. Just to start off, I wanted to let you know that there are different types of double displacement reactions. There will be ones where when the reaction takes place, you will form a solid. Okay, like the one above here. If you look here, it's aqueous. Aqueous. So again, aqueous means that say you've taken the powder magnesium chloride, you dumped it into water, mixed it, and you made a solution. Okay, so when you take a compound, mix it in water, make a solution, the state symbol now becomes, so it would have been a solid, but it becomes aqueous now. Okay, you don't write liquid because it's not a pure substance. It's magnesium chloride and water mixed together, so it's a solution. So aqueous is the state symbol for solutions. Yeah, like if you ever have water, just water in your chemical reactions, then you would write liquid, okay, because that's the pure substance of water. So if it's mixed in water, aqueous. So you have an aqueous substance and another aqueous substance. They're mixed together, and a reaction happens, and double displacement happens here, and so we get two new compounds. And in this case here, so one of them came out aqueous, one of them comes out solid. So we're going to talk about it's not completely solid, but it'll be partially solid. So we're going to look at why we can label this solid as we go through the lesson here. So keep in mind we have reactions that form solids, reactions that will form a gas, and reactions that will form water. So what we're going to do in this lesson is we're going to concentrate a lot on the ones that form a solid. We're going to touch on these other two. The one with gas, again, we can kind of look at it, but we're not going to go too deep into. It's also produced, like the gases that are usually formed aren't safe for schools and so forth. So we can't demonstrate these and so forth. And then the reaction with water we're going to touch on today, and we'll come back to in a different unit as well. Okay, but I think you've seen this last year. So, all right. So we're just going to go through here and just look at some terminology. So the whole idea above here, I talked about how we're taking a solid and mixing it in water and making a solution. Okay, so we just want to, I just want to talk about some of the terminology so you are understanding what I'm saying when I say this word or that word. Solubility terminology. So we are going to be analyzing. So when we have a reaction here, how well does this magnesium hydroxide has a state symbol of S for solid, because what will happen is that it will partially become a solid, and it'll be in this liquid, this mixture here of calcium chloride and magnesium hydroxide. So magnesium hydroxide will be partially aqueous, but then part of it will become solid. So we're going to be studying how much it mixed in today. Okay, so solubility, that's what that is. Okay, so we're trying to figure out how much of the solute, so think of this as like the powder, is mixed into the solvent, which is like the water. Okay, and how much of that can be mixed in at a certain temperature and pressure. Okay, so that's the solubility of a substance. Again, we're just touching on it today, but we will come back to it again in a future unit. This is something soluble. It can dissolve. Like for example, if you take some salt mixed in water, it will dissolve, so it's soluble. Where if you dump oil into water, they don't mix, so you'd say they're not soluble. Like oil is not soluble in water. Okay. So soluble, it can mix. Words that we're gonna use today are low solubility. So basically, we're gonna be looking at a substance. It's partially mixed in there, but it's part of it has become a solid. Okay, so then we would say that compound has low solubility. Okay, so it's not mixing well. But we still give it a state symbol of a solid. Okay, from there, so again, I like to use this picture as an analogy. The solute, think of it as like the crystals. It's what you have less of. It's being dumped into water. The solvent is what you have more of. So solute gets put into the solvent. There's more of the solvent, and it dissolves in there. And then when you mix it up nicely, you shouldn't be able to see the difference between the solute and solvent, and so they call it a solution. So the reason why I have this little chart up here, I think you did it in grade 9, where you have to classify matter. So again, when you had a mixture of substances, you had the two different types of mixtures, homogeneous and heterogeneous. So if you mixed a couple substances together and you couldn't see the difference between them, it was considered a homogeneous mixture, but we also call it a solution. If you could see the difference, like if you put sand and marbles together, you could see the marbles, you can see what the sand is, so that's considered heterogeneous. So we're going to be studying solutions this year. So just make sure, get comfortable with this terminology. It will come back. It'll be used today as well. All right. Okay, so we talked about solute. That's what mixes into the solvent. Okay. So once we do this and we put a couple different substances together, we're going to be looking to see, are they still mixed together? Are they soluble? Or is some sort of reaction happen so that some products form? Okay, so what we're going to see, if we end up seeing a solid, we're going to call it a precipitate. Okay, so if you were in the lab and you were taking a couple aqueous solutions and mixing them together, and then suddenly a solid forms, then you would say you observed a precipitate. Okay, so you're not going to use words like it curdled, it's cloudy, and stuff like that anymore. So we're going to be analyzing chemical formulas today, reactions today, and determine if a precipitate will form or not. Okay, so I'll move on here. So like I said up here, there's 3 types of double displacement reactions. So the first one, where a reaction that forms a solid, that's the one we're going to study here in good detail. So looking here, the description is like you're going to have a couple aqueous solutions being mixed together, and you form a precipitate. So if you get a solid, then it's a precipitation reaction. So here's some examples. Aqueous calcium chloride and aqueous sodium carbonate are mixed together, and you're going to find that there's a precipitate that forms. Okay, there'll be a solid suspended in in the liquid aqueous solution. All right, and here's barium chloride aqueous, potassium sulfate mixed, and potassium chloride will still be soluble. Okay, so you'll still see it in liquid form, and then the barium sulfate will be the precipitate that forms. So we're gonna learn today, how did we know that the barium sulfate or the calcium carbonate here became solids. So there's a solubility table. If you take a look at the back of your periodic table, so here it is. So again, the other day we did the single displacement reaction activity series box here. So if you scroll down here, look at your formula sheet, we have these boxes here, and that's what you're going to use today to determine if a compound is going to be a solid or not. Okay, so this is called the solubility rules table. So I just put some spaces in between the boxes, but it'll be all one big box. I want you to, when you're going about reading these boxes, and to look at the first box first. Okay, don't forget about the first box. So as we go through, you're going to be kind of going through these little points, checking them off, and then deciding if it's going to become a solid or not. So when you react the substances together and you get the products, you need to determine what state symbols that they need to have. So you're going to go through and check to see if you have any group 1 metals. If you have any group 1 metals, so again, if you're looking at your periodic table here, okay, so group 1 is right here. So if you have any of those elements there, you're always going to be soluble. So basically any compound that combines with these will always be, the state symbol would always be aqueous. It'll stay in solution. They'll stay mixed together. Okay. The other types of compounds, anything that's has ammonium in it. So if it's ammonium chloride, ammonium sulfate. So if you have ammonium in your compound name, you are always soluble. Okay, so that soluble again means it'll stay mixed in solution. It will not become a solid. A couple other ones here, nitrate. So if you have these polyatomics, nitrate or acetate, these will always be soluble as well. Okay, so if you ever see any of these features here in box 1, you know you can always just label it aqueous. Okay, so then, so again, if you're wondering, that's what dissociates means. So you're going to go through, put it in water, and it'll stay apart. Okay, it's not going to solidify. Let's go to the next box here now. So what you're doing here is it has the halides, the sulfate, the phosphates, and the chromates. So basically, you're looking at these polyatomic or these anions here, and every single time you see a compound with these conditions for each one, you will form a precipitate. So basically, you need to assign a state symbol of S. So halides, so chlorine, bromine, iodine, if you combine with silver, okay, lead 2, okay, so pay attention to what charge it is, okay, because if it's lead 1, that means it'll be soluble, okay, but if it's lead 2 with chlorine, it will form a precipitate, so it has to be solid. Okay, so here is mercury 1, okay, it's that special one for mercury, okay, like a diatomic metal, so that's mercury 1, copper 1, and thallium, okay. 1. So these are multivalent, so you have to make sure, like silver isn't, but these 4 here are multivalent, so it has to be these specific charges, okay? And if they combine with these halides here, they will form a precipitate. Okay, look at the next one, sulfate. Again, if it combines with these specific metals or cations, okay, it will form a solid. And so forth. Okay, so you don't have to memorize these. These are on the back of your formula on your formula sheet. So here, like if you're looking at phosphate, carbonate, and sulfite, you're noticing, okay, where are the what does it combine with? It just means that anytime you see these guys in some sort of compound, they form precipitate with whatever they combine with. Chromate here, and if it's with these specific cations, then it will form a precipitate. But number 3 here, these guys, they will always just form precipitate with anything. Okay, and so the box 3, the exception box. So basically we have the sulfides and hydroxides. So they will always form precipitates except when they are combined with these. So if you have sulfides here, again, I know it's the pH spelling, but you can have the F and the sulfate here as well, the F. Okay, so the sulfides, so S -2, so if you combine it with these cations here, they will be soluble, so you need to write aqueous. Otherwise, you need to write solid. Okay, and hydroxides, so same thing. If you combine it with these ones, fine, they will mix, they will stay in solution, but if it's anything else, it will form a precipitate and you have to write solid. Okay, so just kind of keep going back and forth, do lots of questions today so that you get comfortable with this. And it's to the point you'll see so many of these that, oh, there's that nitrate again, I know that's soluble, okay, and so forth. So you, and then, yeah, just know that you'll always be given this table here. To get practice before we try some of the examples, why don't we look at the examples that were given up here with the calcium chloride and sodium carbonate, etc. So, so right away they were mixed into solution, into water, and then they were combined together. So for all of the questions that you're doing, just the ones that you start with are always aqueous because we're preparing them in water and we're dumping them together, and then something happens, a reaction happens, which can affect the solubility. Okay, so then on the right side, we're going to decide, is it going to be soluble or not. So let's start with the first one there. So again, we ended up with, so if we didn't know the state symbols now, this is what you would do, because you know you have calcium carbonate, and then you have sodium chloride. Okay, so you're going to go to your solubility table right now and look up calcium carbonate. So right now you're looking through here. Calcium isn't one of the group 1 metals, it's a group 2 metal. Carbonate is not listed here. Okay, so nothing applies in this box. So let's go to the next one here. Halide, sulfate, okay, carbonate right there. Okay, so anytime anything combines with carbonate, it will form a precipitate. So we are going to write in our state symbol solid for that one there. Okay, so little symbol like that. All right, so then we'll go to the next one, sodium chloride. So again, start with box 1, look in here and go, oh, I see sodium. So what did that mean? Anytime anything combines with sodium, a group 1 metal, it is soluble. So right there, you don't even have to look at the rest of the boxes. You know that it's going to be soluble. So you just write in, it's aqueous. Okay. All right, let's try the next example that we had at the top there. So if you had potassium chloride and barium sulfate. Okay, so again, when you're writing in the state symbols, the ones that you start with, the reactants, just put them aqueous. Okay, then we're reacting them, and now we're deciding, okay, potassium chloride, barium sulfate. What type of state symbols will they have? Because will they stay in solution, or will they be soluble, or will they not be soluble? So let's start with potassium chloride first. So you're looking up in here, and right away you see potassium. Okay, it's a group 1 metal. Anything that combines with a group 1 metal is aqueous. So write AQ. Okay. All right, and barium sulfate. Let's go find barium sulfate now. So I'm looking up here. Do I see anything about barium? No, barium is a group 2 metal, so it has nothing to do in there. Sulfate's not here, so let's go to the next box here. Sulfate. Okay, so here's sulfate. So what did this box say? Well, if sulfate combines with calcium, strontium, barium, lead 2+, or radium, it will form a precipitate. So yes, barium will, when combined with sulfate, becomes a precipitate. So write in that it's a solid. Okay. So that's what you're doing today. For example, when you're going to go through and do what you've been doing right from the beginning of this unit, where you read a description and you need to get it into a skeleton equation, and then you need to predict the products. We know it's going to be a double displacement reaction, and then we're going to need to decide what type of state symbols that they have today. Okay, so really in the end, the new thing is figuring out the state symbols today using these solubility rules. All right, so let's go to example 1. Okay, so the question says, will a precipitate form if potassium chloride and silver nitrate are reacted together? Write out a chemical equation for the reaction, write the state symbols. Okay, so again, as you're going through, you can go ahead and balance, practice all the stuff that you've been learning. Okay, if you wanted to write a word equation, a skeleton equation, then balance it, all that stuff, that's good. But the main things here today is I want to see those state symbols now. So potassium chloride, so let's write that out. So again, if it helps you to do the work, as you're still trying to improve how your nomenclature is going. So here's potassium chloride. So if you wanted to do the work and go, okay, potassium is a +1 charge, chlorine is a -1 charge. Okay, so so you would write potassium chloride like that. Okay, 1 to 1. All right, then we have silver. We have silver nitrate. Okay, so just sometimes if the compound name gets cut off in a way onto the next line of the sentence, just kind of keep reading through and know, oh, that's actually the compound silver nitrate, not silver and nitrate, because some of you did that on the previous checkpoint. Okay, so silver nitrate is the compound. So again, we're just going to go through here and go, okay, well, silver has a +1 charge. Nitrate, okay, is a polyatomic. It's a -1. Okay, so when they combine together, it makes a silver nitrate compound. Okay, and again, like I said before, this is a double displacement reaction. Write the products out, and then we'll do the state symbols. Okay, all right. So potassium comes in. So we'll swap places with silver. Again, please do not use the activity series for double displacement. Okay, don't look at that anymore. Turn that off. Again, I don't want you to be looking at this and deciding if the product's going to form or not and so forth. Okay, you're not doing that here because these are a compound comes in and mixes with another compound and you're getting a reaction and determine state symbols. You are not having an element come in and mix with a compound. It's a compound with another compound. So don't use this activity series when you know it's a double displacement reaction. Okay, so potassium's coming in, potassium chloride, they're going to swap places here. So we're going to end up with, so again, if we have our ions all here, just think, okay, potassium and nitrate are going to go together, and chlorate and silver will go together. So let's make those compounds here. Okay, 1 for 1. Okay, or if you want to think of as crisscross. Okay, silver and chlorine. There we go. Okay, so we have our chemical reaction equation. So now we have to determine the state symbols. Okay, so again, like I said, like right here, even in the description, it says the solutions of potassium. So they are aqueous. Okay, so just whenever you're putting these in, the reactants are always aqueous. Okay, so we're going to mix them in water, take the powder, mix them in water, and then we dump them together and then look at the reaction and see if some what type of products form. Okay, so we have potassium nitrate is the first one. So let's scroll back up to our solubility table here. Potassium nitrate. So right away you see potassium, okay, and even nitrate. You're like, oh yeah, that is definitely soluble. So you're going to write AQ. Okay, all right, so the next one's silver chloride. So again, you don't see silver up in the first box at all. Okay, so move to the next one, halides. All right, so we see chlorine here and silver. So if these guys ever combine together, they form a precipitate. So you're going to write solid. All right, and you're good to go. Okay, so let's try the next one. Example 2. Okay, so and then if I guess back with example 1, it says, will a precipitate form? You should, I guess, answer that question. Yes, a precipitate will form. Okay, so therefore, yes, a precipitate will. Okay, and if you're in the lab and you're making quick observations, chemists like to abbreviate precipitate as PPT. Okay, so if you are wanting to quickly jot down your observation, oh, I saw a precipitate, you don't have to write precipitate, you can just write PPT. Okay, let's go to example 2. All right, so will a precipitate form if solutions of potassium sulfate and iron 3 chloride are combined? Okay, so again, you need to build your chemical equations, so you need your nomenclature. Okay, so there's potassium, here's sulfate. Okay, and here's iron 3 chloride. So it's saying iron 3. Okay, the Roman numerals tell you what charge for iron, and chlorine is always -1. Okay, so let's make those compounds. Potassium sulfate. Okay, so we need two potassiums to one sulfate to balance out the charges, okay, or crisscross. And here we need one iron and three chlorines to balance out the charges. Okay, so again, you have a compound and another ionic compound. So you have a double displacement reaction here. So you're going to swap places. The metals will swap places. Okay, and so you end up with potassium and chlorine now. Okay, and iron will go with sulfate. Okay, and then double check your work, make sure everything looks good. Yes. Okay, so now you have your compounds here. You have to find your state symbols now. So go and use your solubility table. Okay, so let's start with potassium sulfate here. Okay, so scroll up. Potassium, potassium. Yep, there it is. Potassium is always soluble with anything it combines with. Oops. Okay, so you are going to write. Oh, and you know what? On top of it, sorry, these are the reactants. So just write aqueous. Okay, so right away it says here solutions of. All right, so we need to figure out potassium chloride. Sorry. Okay, so potassium again. Yep, potassium. Anything with potassium is aqueous. It'll stay in solution. All right, let's look up iron sulfate. So sulfate. Okay, iron 3. Nope, not in the first box. Okay, and then sulfate. Yep, there it is. Iron 3. Okay, you don't see iron 3 here on the list here. Okay, so because sulfate, when it's combined with these ones, will form a precipitate, but you don't see iron 3 there, so iron 3 is also aqueous. And so that's what will happen sometimes. You'll take a couple liquids, mix them together, and yeah, they both still stay in solution. No precipitate forms, and so forth. Okay, so we need a therefore statement for this one. So it asked if a precipitate will form, and you would say therefore no precipitate will form. Okay, so hopefully that was enough practice using the solubility table. So again, what you're doing today, you're going to have some practice questions where you're going to get a couple ionic compounds. They're always aqueous. You're going to mix them together and you're going to predict the products that will form. Okay, so you just swap the places where the metals are. You need to come up with the right formula. So again, this is where you have to have your nomenclature down. And then you have to tell me what the state symbols are. Okay, so again, it's either aqueous or solid. For like the practice questions today, we're going to look at the other type of reactions in a second here, but the main things here is this is what you're practicing today. Make sure you can figure out the state symbol. Is it going to stay in solution or is it going to precipitate out? Okay, so let's move on to the other type of reactions that can happen with double displacement. So again, the ones above were the ones that form a solid. There are ones that form a gas that are out there. So I just wanted to kind of point them out to you, but we're not going to go into too much detail with these ones here. So if you take sulfides, carbonates, sulfites, and mix them with the acids, you're going to form a gas. Okay, that's kind of like the general idea here. So here are some gases like hydrogen sulfide. We don't want to do any of these type of reactions in school because we don't want to be breathing in any type of sulfur gases. Carbon dioxide's formed here. Okay, sulfur dioxide's formed out of here. I think you can get ammonia gas as well, and so forth. So there are these double displacement reactions. Okay. Okay, but yeah, so that's just, I just want to introduce them. I'm not going to make you uh, show the state symbols for these ones, okay? All right, so here's a third type of double displacement reaction. It's the ones that form water. You would have studied them last year. Um, they were called acid-base reactions or neutralization reactions. So basically what's happening here is you have an acid and then a base, and they're being mixed together, and one of the products is water. The other one is like a salt ionic compound. This reaction has great applications when there's issues with, like, there's been a big acid spill somewhere, so they can use a base to neutralize it. Okay, because water is a lot safer than a base or an acid. Um, so again, we're going to study these in more detail, but we're going to analyze things like the pH and so forth. But again, we can't determine, like, there's no precipitate form, so we can't really analyze too much with these reactions, because you mix them together and it still looks like like it might be two colorless liquids mixed together, and then what forms is there's some new products that form, but it still looks like colorless liquids. So we have to perform some other operations like titrations and so forth, which we will study in a future unit. Okay, so just wanted to point out that there are these other types of double displacement reactions, but I want you to concentrate on these ones where they form a solid. So they're called the precipitation reactions. Okay, all right. So if we scroll down here, here are the practice questions here, and I probably have some worksheets that you can use as well. So again, try them. And remember, check your answer, make sure you're good to go, and then try the checkpoint. Okay.